9 says, find the inverse of the function g of x equals 2 to the x power and demonstrate it as the inverse using input-output pairs. So it's another way to say the same stuff we've been thinking about so far. So let's find the inverse of g of x equals 2 to the x. So what I'm going to do is just make a table of values. So I've gone over here to my calculator and I've typed it into y equals. I'm going to go to second graph to check out some values in my table. So let's just put some simple ones. -2, -1, 0, 1, and 2 usually work pretty well for most functions, but sometimes you need a little more. But let's write those down. So I am just writing them on my paper from the calculator and demonstrate it as the inverse using input-output pairs. So we found our input-output for our original function. The inverse of that would be if we take the x and y and we switch them. Let me scoot it over a little bit. So if we switch them, we have the inverse function. So we'd have 0.25 goes with -2. 0.5 goes with -1, 1, 0, 2, 1, and 4, 2. All right, so I'm going to graph the original one in green. So -2 goes with 0.25, -1 is 0.5, 0 goes with 1, 1 is with 2, and 2 goes with 4. So that's our original function, g of x. And then the inverse function, we just switched each x and y value. So let's go to 0.25, -2, and plot that one. 0.5, -1, 1, 0, 2, 1, and 4, 2. And that is our inverse of g of x. So it said to find the inverse, so we did that by switching x and y just from our table. We demonstrated it as the inverse using the input-output pairs. So we've plotted them. Let's just add one more thing to our graph. Notice that these inverse functions always will reflect over this line y equals x. So that's a nice thing to just draw on our graph while we have another example. All right, so that's it for example 9.